Hey there, folks. Happy Tuesday. Hey, I'm super excited to share this with you, except the fact that we really don't have sun. So, I may do this again on another sunnier day. But we're going to go ahead and do it. It's what I had first scheduled today, and that's what we're going to do. So for today's lesson, what you are going to need is the worksheet that I sent to you, where it's Show What You Know #1. You're going to need that handout. And then when you're ready, you're going to need a recyclable water bottle, because you are going to have to cut a hole into it. Okay, so there's a hole right there to cut a hole into that guy. And then you're going to need 2 thermometers. And so I don't know if this is what you'll have in your home. So this may be something that you just kind of watch with me and kind of check in with me. But then you're going to need thermometers. So this one will be sitting outside of my water bottle. And then my other one I will be sticking inside that hole inside the water bottle. And then you're going to need water, right? So we got this water right here. Bam. So I got a cup of water with a little spout, so it's a little easy to pour into there, right? So what we're going to do is we are going to take we are going to check and test the fact that water holds energy. So last week I explored that a little bit with lower L. We took a balloon and we put a little bit of water in the balloon and hovered that balloon over a flame. An open flame, and saw what happened. And so you would think that the balloon would pop, because when we just blew up a balloon and put it over the flame, it popped as soon as it touched the flame. And it didn't even get to touch it. As soon as it got close to the flame, about an inch away, it would pop. But then when we put about a tablespoon of water into the balloon and then blow it up, and we would hover it over the flame, you could have the flame touching the rubber or the balloon, and it was not burning. This black soot was collected onto the balloon, indicating that the water within the balloon was absorbing the heat, allowing the rubber to withstand more or a hotter temperature. Okay, cool. So that being said, that indicated that water absorbed energy. Well, this is another experiment where we could do that. It is an experiment where we can test exactly what is the difference. So I'm taking 2 thermometers, regular old thermometers that are sitting at room temperature, that are sitting out in their same environment, and we're going to put 1 thermometer inside of water that is surrounded by a plastic, which is then like a greenhouse effect, right? Greenhouse effect. So the thermometer is going to experience that within the water, and then we're going to have 1 outside of it, and we're going to test, like, what's the difference? Is there a difference? I don't know. So, like I said, today is not very sunny. So, it's not going to work the best, but the sun is still out. The rays are still penetrating through the clouds, just not strong rays and not all the rays, right? So, we'll test it. We'll see how it goes. And then on our next sunny day, I'll probably do pictures of before and after, like before the thermometers, like as soon as they start, and then about an hour and a half after. If you do have this material, the longer you allow the thermometers to sit in their environment, so outside and in the water, the better your results will be. So right now, if we go off Fahrenheit, because a thermometer has 2 different measurements. It's got Celsius and it's got Fahrenheit. We're going to look at Fahrenheit. It's what we're used to. It's what, we associate our days with. How hot is it outside? Oh, it's about, like right now, the temperature outside, my clock says it is 50 degrees outside my house. Okay, it's 50 degrees outside my house right now. And so I'm curious to see how that affects. Now, inside my house, my thermometer says it is 73 degrees. But on here, yeah, it's about 73 degrees. So that's pretty cool. So inside my house is about 73 degrees. And we're going to go outside and we're going to change it. So here goes nothing. So, but first, before we do that, I'm going to prop this up here so you can see it. We are going to fill this up with water. Do it to your best. I would do this where you have hard surface. You don't want to get water in your house, right? You don't want to upset mom, or dad, or granny, depending on where you're at. Okay, so I'm going to put a towel down just in case because I'm pretty klutzy. So here we go. We're going to pour some water in. I would pour in enough water so that when your thermometer's in there, it is touching. So you got to pour a nice amount of water in there This is obviously a little over a cup, and it will do its job. All right, so there we have it. Put the lid back on. You want to close off as much holes as you can. And then we're going to take the thermometer and place it inside the hole that has already been cut. So, and we're going to make sure that the part where the measuring is, it's actually in the water. You don't want to put it upside down. That wouldn't make any sense. Got to make sure that part that's measuring it is in the actual environment, right? Bloop. So there it is. So thermometer is in the environment, the water, and this thermometer will be outside of it. And I'm actually going to like prop it up like that. And so it will be right beside each other, one on the outside, one on the inside, and then we'll decide. And so that's some friends calling. So that's what you got to do. Okay. So what questions we're going to have to decipher, and you'll be able to, even if you don't have the material, friends, I'm going to, in an hour and a half, I'm going to post the difference. So when I end this video, I'm going to take a picture of what we're experiencing, and then I'm going to take a picture of what the temperatures are in an hour and a half, and then you'll be able to answer these questions. The questions you will find on your worksheet right here. The question is, you know, do both thermometers record the same temperature? I don't know. I would like you to think about that kind of beforehand, because then you're kind of making that hypothesis. Is it going to change? Is this going to be affected? Are they going to be different? And you kind of think, well, is it? I don't know. And then if the answer is no for question 1, which one is higher? Which one is higher? So I think it'd be cool to answer these questions offhand, like before you even test it. Like, so which one's going to be a higher temperature? Do you guys think the thermometer on the inside is going to be a warmer temperature? Or do you think the one on the outside is going to be a warmer temperature? It's a good question. And why do you think these two temperatures are not the same? I want you to think back to that balloon experiment. Why are they not the same? What is going on with that water? And then how do you think this is similar to the greenhouse effect on Earth? So how is this experiment what we experiment with our heat from the sun rays here on Earth? Those are awesome questions. So there it is, kids. So there's a Tuesday experiment. I am going to take a picture, and then I will take another picture in an hour and a half. So by the end of the day at, what time is it? Yeah, and about 3:30. Okay, about 3:30, 4 o'clock. All right, you guys have a great Tuesday, and keep an eye out for the photos. Can't wait to see what you think. Looking forward to your answers. Hope you all have a good Tuesday, and I'll see you tomorrow. Bye for now, friends.